Welcome to Exquisite. In this class, we will be learning about the principles that let us know how images are formed by curved mirrors.
Sensei, please explain more.
Okay, this is it. Suppose we have a concave mirror like this one. If I stand some distances away in front of the mirror, then my image is formed somewhere there. In optics, the real material is called the object, whereas the guy formed by the mirror is called the image.
Sounds very clear.
Now, if I move closer to the mirror or farther away from it, the type of my image formed by the mirror changes. The image can grow bigger or smaller, it can be real or virtual, upright or inverted, and so on. We will get to see all these in subsequent videos.
Okay.
There are 3 of these principles, and we will apply them in subsequent videos. Let's start with the first. Again, if this is our concave mirror, we had learned from our previous video that this imaginary line is called the principal axis of the mirror. Now, if this point is the mirror's center of curvature, then the principal focus is the point midway between the center of curvature and the mirror.
Yes, Sensei, I remember these things from the previous class.
Great. Now, the first principle says that, if a ray is parallel to the principal axis, after reflection on the mirror, it must pass through the principal focus.
Oh. So it can't go any other way?
Yes, Titi. So long as it came in parallel to the principal axis, it must lead through the principal focus. No other way.
Okay, I got it. A ray parallel to the principal axis must pass through the principal focus after reflection on the mirror.
Good. The second principle says that, if a ray passes through the center of curvature, it must also return through the center of curvature after reflection on the mirror.
This looks like a case of coming in and leaving through the same door.
Yes, exactly so. A ray that comes in through the center of curvature must also leave through the center of curvature.
Oh. Okay, I wonder what happens if the ray comes in through the principal focus. Will it also leave through the principal focus?
Haha, no Titi, it does not happen that way. A ray that enters through the principal focus does not leave through the principal focus, rather it leaves through a path that is parallel to the principal axis. And that is actually the third principle.
Really? Okay. Please help me understand it well.
The third principle says that, if a ray passes through the principal focus, it will return parallel to the principal axis after reflection on the mirror. If you look at it clearly, Titi, you will realize this is the reverse of the first principle.
Yes. Sensei, I get it, because the first principle says that if the ray comes in parallel to the principal axis, it will leave through the principal focus. And this time, a ray that enters through the principal focus will leave parallel to the principal axis. The exact reverse path of the first.
Yes, Titi. This kind of thing is called the principle of reversibility of light. And it specifies that the path of light will always be the same if we reverse the direction of travel of the light.
Oh. That's true. Light comes in parallel to the principal axis and leaves through principal focus. Then if I send it back in through the principal focus, it's going to leave parallel to the principal axis. This makes it easy for me to remember the 2 principles.
Nice. And that brings us to the end of this class.
I'm happy. Sensei. The end came so quickly.
So please give us a recap of the things you learned in this class.
Very simple and interesting.
Okay.
1. If a ray enters parallel to the principal axis, it will leave through the principal focus after reflection on a curved mirror. 2. If it enters through the principal focus, it will leave parallel to the principal axis. And finally, number 3. If a ray enters through the center of curvature, it will also leave through the center of curvature.
That's great, Titi. See you in the next classes where we will apply these principles to see how images appear in curved mirrors.